So let's go ahead and do an example and finish it off that way. So example 2, we'll use the same vector field as before. So we have f is equal to, we said it was cosine of xy, excuse me, and sine of x squared y. Okay. Now let's go ahead and do our c of t. So our curve c of t is going to be 4 cosine t 2 sine t, which is the ellipse that has a major focal radius of 4 and a minor focal radius of 2, centered at the origin. Or if I write it in Cartesian coordinates, it'll be x squared plus 4y squared equals 16. So this is just two different ways of representing the same thing. This is the parameterized version. This is the Cartesian version. Okay. Well, we found the curl already. The curl of f, we found it already. That's equal to 2xy cosine of x squared y plus x times the sine of xy. Okay. So now let's go ahead and solve this. Green's theorem says that the integral over a closed curve of this vector field dotted with c prime, in other words, the circulation, is equal to the double integral over that of the curl of f. It's often a good idea to repeat the formula, write it over, dy dx. Well, this is going to equal, let me go ahead and draw this region here. This is an ellipse, like that. This is minus 4, this is 4, this is 2, this is minus 2. So x, we're going to go from minus 4 to 4. Again, we're solving a double integral. We need to find the region over which, that's what a double integral is. X is going from minus 4 to 4, right? And now we're going to have to take little strips of y because now we're going to go from y. So now y, in this particular case, I'm going to leave it in terms of x squared, y squared, because I'm not doing the parameterization. I'm not doing the line integral. I'm actually doing the area integral. So x squared plus 4y squared equals 16. I get 4y squared equals 16 minus x squared. Y squared equals 16 minus x squared over 4. So y equals plus or minus 16 minus x squared over 2. So y is going from minus radical 16 minus x squared all over 2 to plus radical 16 minus x squared over 2. And of course, I have my function here, which is the curl, 2xy times the cosine of x squared y plus x times sine xy times dy dx. And then when I end up putting this into my mathematical software, I get 0. So, this is what's interesting. Remember, we found the curl at a certain point. The curl was negative. So, despite the fact that we had the curl of f evaluated at the point pi over 2, 1 was equal to negative 0.879, the net curl equals 0. In other words, this vector field over this region is not rotating this way or this way. When the curl equals 0, we call the vector field irrotational. This vector field is irrotational. That's it. Straight mathematics. Okay, so when we meet again next time, we'll talk about the flux divergence version of Green's theorem. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.